So hi guys, to another YouTube video. Now we will see the inverse square law. So what is the inverse square law? It states us that as the distance will increase, the force will decrease. So inverse square law is given by f bar of r equals to k upon r square r cap. It's a vector form of it. So here k is a constant, r square is a distance. So you can say that f is inversely proportional to 1 upon r square. Now in this formula, k can be anything. Okay. So for as you know, gravitational formula for that, k will be minus g equals m1 m2, and for Coulomb k will be q1 upon q2 q1 q2 into 4 pi epsilon 0. So now if k is negative, it will denote the attraction, that is negative, and if k is positive, it will denote repulsion. So as you can see, when two things come towards each other, their distance decreases, so negative. Now when two things go away from each other, their distance increases, that's why a positive sign. So now for potential energy, it is also not a square, it's an inverse relation. So for potential energy, it is k upon just r. Okay, since v is di by f by di by r, it's negative sign. So we can say that effective potential energy can be given by k upon r plus L square upon 2mr square. Okay, clear till now? So now from this we can say that total energy E will be given by Ke plus V effective. So Ke is 1 by 2 mr dot square plus V effective from here is k upon r plus L square upon 2 mr square. Okay. So now from this relation we will see this whole graph. Okay. So now k can assume any value. So now let's see what are those values. If value of k is greater than 0, okay, k is greater than 0, that means this k is increasing. So if k is greater than 0, it will show us repulsive force. Okay, see, the k is increasing, my energy is increasing. Now it is related to r, so let's go into the further more deep. So now if k is increasing above some point, so okay, the particle will have energy even over here. Now my k is increasing, so particle will come closer, closer, closer. Now after some time this particle will be repelled. It will be reflected. It will be reflected back. So this is the example of. So this is the case of scattering of particle. Scattering of particles. Okay. It's double T over here. Now the next case is k equals to 0. Okay. So if k is equal to the 0, the particle will have no energy and it will go constant in the straight line until and unless it is moving away from the origin. Now if any particle is coming towards the origin, you can see this, if k is 0, then this whole term cancels, this whole term goes, but still in formula you have this r square. So if particle is coming towards this, then this term becomes less, this goes on decreasing as particles moves towards the origin, towards the center of the particle, towards the central force. So its energy will goes on increasing. Okay. So now next case is k is less than 0. This case k is less than 0, but L is not equal to 0. Okay. So L not equals to 0. So what will happen is, see this graph, from right to left we are coming over here, we are having such a dip and then we are going up. Okay, So now this value can be positive or negative, hold this E, depending upon the magnitude of the K. Okay, now this whole value depends upon magnitude of this value. So if V is negative, say if this whole values goes negative, then it will be show bounded motion, and if E is positive, it will show unbounded motion. So bounded motion, it means the motion is bounded to certain area, certain path. That is circular motion around of planets around the sun, or of moon around our earth, or motion of electrons around the atom. And if unbounded means it can go haywire, anywhere, it can go straight, round, random, anything. Okay, so now let's do some short derivation. We know that d of V effective upon dr, whole that r equals to r0 is 0. Now we know that minus k upon r0 square minus l square upon m r0 cube equals to 0. Okay, we have got that from over here. Okay, from over here to here. Or we can say r0 equals to minus l square whole upon mk. So we can say V effective at r0, if r equals to r0, it becomes minus mk square upon